All right, so today we're going to use first and second differences to determine if the table is best modeled by a linear or a quadratic function. So this is the third way and the last way. And we can do this with first and second differences as long as you have consecutive equal length input value intervals. Now, I've said that a whole lot the last couple of days. Today we're going to write it a whole lot just to make sure everyone gets the wording down. And so if you find the first differences in the output values, so you subtract the output values and you get the same number every time, what type of function do you think it is, linear or quadratic? It's linear, good. All right, and then the second difference is if you take those first differences and subtract them, and if you get the same thing all the way through, that's going to be quadratic. And again, this only works if your input values have equal length. And so all the ones that we're doing today, they do have equal length. You're going up by the same amount each time. So it's okay just to use these first and second differences. All right, so what I did on these examples and on your assignment is I worded it exactly like what it will look like, almost exactly like what it will look like on the AP exam. The difference is the AP exam won't say just linear and quadratic. I'll have to look at it, but it might be quadratic or cubic or exponential or logarithmic. We haven't learned enough to answer all those questions yet. So we're just going to stick with these two. So linear, quadratic, or neither will be it for today. And like I said, we'll just build on it later. Okay, and so when you're finding the first and second differences, this is on the calculator version of the AP exam, and so you can subtract them in the calculator. You can just find the amount of change in your head if you would rather do that. So if you're going to subtract, what you would do is take one of them and subtract the previous one from it. And so we would take 7 and subtract 8, and that's going to be -1. If you're just thinking about how much did it change, you just look at 8. It went down by 1 to get to 7, so that's a -1. So however you want to do it, it doesn't matter to me. And when it's easier numbers, like these first two, I like to just think about how much it changed, but whatever. When you get down to this one right here, you might want to pull out your calculator unless you like to do a lot of subtraction in your head. All right, and so to go from 7 to 8, it's going up by 1, up by 3, and then up by 5. The other option is to just do like 16 minus 11 to get the 5. So the difference in what we are doing today and what we've been doing before we were doing the average rate of change. So we would find that change, and then we'd also have to divide it by the change in x. We're not doing that today. We're just subtracting the y's. All right, so not linear. And so now what we would do is subtract these differences. And so you can either do 1 minus -1, or you can think about how much it changed as you went from one to the next. All right, so what do you guys think? What is this best modeled by? Quadratic. The second differences are the same, and so it's going to be quadratic. But we're going to write a nice, pretty sentence. We're not just going to say quadratic. We're going to practice perfection on these. If you are a little short of perfection on the actual test, you'll probably still get your point, but we want to practice perfection. And so what you would want to do is write a sentence that says f of x is best modeled by a quadratic function. And then on number 2, you need to articulate the answer very precisely. And so it says to give a reason for your answer based on the relationship between the change in output values of F and the change in input values of F. If you just say that the second differences are the same, you didn't mention output or input. You didn't mention how they changed. You kind of mentioned how output changed. It's just not enough. You're right. You just did not say enough. So let me show you exactly how, or exactly the best way to write this. So it is because the second differences were the same. So we would start off with the second differences. Were they the differences of the input values, or were they the differences of the output values? The outputs. You have to say that in output values. Are a constant. And I like to go ahead and tell what the constant is. So we're going to say a constant 2. But we haven't mentioned the input values yet. And so the change in input values is that consecutive equal length input value intervals. So after this, we need to say over consecutive equal length input value intervals. Now, I had some students last year make up an acronym to help remember all those words. I don't remember the acronym though. It was Kaylee Merriman. If you guys know her, you can ask her. She might still remember it. She's on my list of people who made a 5 on their test last year. So. All right, so let's look at the next one. Are you guys okay with that? All those words? It's a lot of writing today, but the math isn't too bad. You just have to be able to subtract. All right, so this next one. Our input values are increasing by the same amount each time. We're increasing by 2. So we can just find the first differences by either taking one and subtracting the previous one or seeing how much they change. So how much are they changing? 3. So what type of function? Yes. And then we just need to articulate number 2 perfectly. It's going to look very similar to the other one. The difference is instead of second differences, it's going to be first differences, and they're constant 3. That's the only difference in the wording.
We have to divide it by the 2, or not?
We don't. So when we do first and second differences, we just subtract. We don't have to divide. If you were doing average rate of change, you would divide. All right, so I want you guys to try the next one on your own. You might want to pull out a calculator for this one. It's up to you. If you like subtract it in your head, it's fine, but there's some, they get kind of large negative numbers. Any questions on it? Okay, let's do one more together. So on this one, when I find those differences, and you guys might have done it while you were waiting, it's going to be 2, 4, 8, 16. So obviously not going to be linear. All right, and then I subtract again, and I get 2, 4, 8. So is this one going to be quadratic? No. So this is a neither. This one, when we'll talk about it later, when you see that there's a pattern that you're multiplying by something each time, it's an exponential function. But for today, when we're just talking about quadratic and linear, this one's going to be neither. And we're going to go ahead and give the reason similarly, just to practice our wording. So we would say the first and second differences in output values are not constant. Talk about the input values. So what questions do you guys have about first and second differences? Okay. All right. So your assignment is on the back. I'm going to leave up like that first quadratic one. So you can kind of see the wording, and last class they were like flipping over and over. I'm sure it got kind of annoying. So I'll leave that up for you guys.